In this video, I'd like to take a look at our die rolling simulation in action. Now, in the next video, we're going to interactively develop that in an IPython session. However, for the purpose of this video, I have provided a script called rolldie.py, which you can execute as follows. So, rolldie.py, and you provide as an argument the number of times you would like to roll the die for simulation purposes. So let's say, for argument's sake, that we want to roll the die 600 times. Now, if you can imagine having a die in your hand and rolling it one at a time and keeping track of the ones, the twos, the threes, the fours, the fives, and the sixes, and then eventually calculating percentages and things on your own, you can quickly get a sense of why it's nice to be able to simulate things like this in the context of a programming language. Now, separately, for a lot of the other programming languages that I've worked with over the years, we've often written books where we showed you the graphics primitives for creating bar charts and other things like this. In Python, it's very common to use libraries of existing code that can automatically produce diagrams like the one that you see here. So this is produced with a combination of capabilities from Matplotlib and Seaborn, so we'll talk about those in the source code in the next video. Now, as you can see here, there's a number of different aspects to this diagram. We have the colored bars. The color has no specific meaning in this example. Those are just the default colors that are being provided. You see along the bottom that it has labeled 1 through 6, the die faces. We specified the text die value, but Seaborn and Matplotlib figured out, based on the values being plotted, that each of these should be labeled 1 through 6 for us. We specified over here on the left frequency, but Matplotlib and Seaborn figured out the scale of this graph automatically for us. We specified the title of the diagram. We did specify the text above each of the bars as well, and we'll show you the code for all of those things as we proceed to the next video momentarily. Now, of course, if this is a good random number generator and you roll a 6-sided die 600 times, you should get approximately 100 of each die face, and that would be 16.667%. And as you can see, we have 1, 2, 3, 4 of them that came in a little bit above 16.667, and we have a couple that came in below 16.667. So we're not quite right at 100 or so of each individual face, but really each die face should occur approximately 1/6 of the time. Now, as you roll the die more and more, these bars should balance out, which would be an example of the law of large numbers at work. So as we run this program again in a few moments here, and we go to, say, 60,000 die rolls, where we expect to get then 10,000 of each, the bars will be a little closer together, and when we go to 6 million rolls, they're going to look nearly identical in length as a result of the law of large numbers. So we're going to show you how to customize the different elements that you see here on the screen, and as we proceed forward into subsequent lessons, we're going to show you how to do dynamic bar charts like this, where you see the bars changing as the simulation is ongoing. So we have that actually in the next lesson's Intro to Data Science section, and for that we'll use some animation techniques that are built into the Matplotlib visualization library. So let me go ahead and close this window, and let's run this again, but this time let's run it with 60,000 die rolls. And of course it has to go ahead and do those calculations and produce the graph. And as you can see here, the bars are significantly closer in size. All of them are in the 16 point something % range now. Some a little bit higher than 16.667 and some a little bit lower than 16.667, but they're all pretty close to 10,000 at this point and where that law of large numbers is coming into play now. And finally, if we take this a step further and go to 6 million rolls of the dice, that'll take a few moments longer, but we will now see our diagram pop up on the screen, and when we do, we're going to see 6 bars that look like they're pretty much the same height. Of course, by looking at the totals, we can tell that they're not identical, and by looking at the percentages, we can tell that they're not identical. But you can see 16.662, 16.69, 16.67, 16.6. Each of them starts out with 16.6, so we're zeroing in on that 16.667% as a result of the law of large numbers in action. So in the next video, we're going to actually interactively develop the diagram that you see here, and we'll show you the different libraries that you need to produce this and talk some more about the customizations that we did as well.